When massive stars die, they don't go quietly. Instead, they create the most powerful explosions in our universe, supernovae. These cosmic fireworks light up entire galaxies and create the building blocks of life itself. Let's explore how these cosmic giants meet their explosive end. Deep inside massive stars, nuclear fusion creates heavier and heavier elements, starting with hydrogen becoming helium, then carbon, and so on. But there's a catch. Once iron forms in the star's core, fusion stops producing energy. Without this energy pushing outward, the star's massive weight comes crashing down. In just seconds, the core collapses with such force that it rebounds, sending shock waves that tear through the star's outer layers. The temperature spikes to billions of degrees, and boom, we get a supernova. This explosion is so bright it can outshine entire galaxies, releasing more energy in a few weeks than our sun will in its entire lifetime. Not all stellar explosions are created equal. The most common type happens when a white dwarf star steals matter from a nearby companion star. Once it gets too heavy, about 1.4 times the mass of our Sun, it explodes in what we call a Type Ia supernova. These explosions are so similar that astronomers use them as cosmic measuring sticks. Then there are core collapse supernova, where massive stars explode after running out of fuel. But the most dramatic are hypernovae, supercharged explosions that create powerful gamma-ray bursts. These cosmic monsters release more energy in a few seconds than our Sun will in 10 billion years. Astronomers think these might happen when really massive stars collapse into black holes while spinning super fast. The energy released in a supernova is mind-blowing. Imagine all the energy our Sun will produce over its entire 10 billion year life. Now pack that into just a few seconds. That's what we're dealing with here. When a massive star explodes, it briefly becomes as bright as 100 billion suns. The blast sends out enough energy to power all of Earth's electricity needs for 1 trillion years. The temperature at the center reaches an incredible 100 billion degrees. That's about 20,000 times hotter than the Sun's core. This massive burst of energy doesn't just create light, it generates powerful shock waves that race through space at millions of miles per hour, pushing out huge clouds of gas and dust that will eventually form new stars and planets. Let's talk about how supernovae work as cosmic factories, creating the building blocks of our universe. During these massive explosions, the intense heat and pressure forge elements we use every day. The iron in your blood, the calcium in your bones, and the gold in jewelry. All of these were cooked up in ancient supernovae. The process works like this. As the star explodes, lighter elements smash together with incredible force, creating heavier ones. It's like a cosmic pressure cooker working at temperatures millions of times hotter than your kitchen stove. These newly formed elements spray out into space, mixing with gas clouds that will eventually form new stars, planets, and yes, even you and me. The next time you look at a gold ring or take a vitamin supplement, remember, those atoms were forged in the heart of an exploding star. Throughout history, humans have watched these cosmic explosions light up our skies. In 1054, Chinese astronomers spotted what they called a guest star, so bright you could see it during the day. This explosion created what we now call the Crab Nebula. Fast forward to 1987, when astronomers caught supernova 1987A in action, the closest supernova we've seen in modern times. It gave us an amazing chance to study these explosions up close. The most famous might be Tycho's star from 1572, which helped prove that the heavens weren't unchanging, as people believed back then. Today we use powerful telescopes to spot supernovae in distant galaxies almost every night, helping us understand how these cosmic fireworks shaped our universe. The Crab Nebula stands as one of the most amazing objects in our night sky, a beautiful reminder of a star that exploded nearly 1,000 years ago. What we see today is a cloud of gas and dust spanning 10 light-years across, all lit up by a tiny, superdense star at its center. This leftover star, called a pulsar, spins 30 times every second, sending out beams of radiation like a cosmic lighthouse. The nebula itself is still expanding, with all that stellar material moving outward at about 3 million miles per hour. When you look at photos of the Crab Nebula, you're seeing delicate threads of gas glowing in different colors: red from hydrogen, blue from high-energy electrons, and green from oxygen. Finding supernovae used to be like searching for a needle in a cosmic haystack, but modern technology has transformed this hunt into a well-oiled machine. Today's astronomers use robotic telescopes that automatically scan huge sections of the night sky, taking thousands of pictures. Special computer programs compare new images with old ones, looking for any bright spots that weren't there before. When they spot something new, they alert astronomers right away. Teams around the world also use special cameras that can spot the unique light signature of exploding stars, even in distant galaxies. Citizen scientists help too. Everyday people looking through telescope images online have found hundreds of supernovae. Thanks to these methods, we now discover about 1,000 supernovae every year. The death of stars through supernovae isn't just an ending, it's also an amazing beginning. When these stars explode, they spread clouds of gas and dust across space, creating what we call stellar nurseries. These cosmic clouds are packed with elements like carbon, oxygen, and nitrogen, the basic ingredients for making new stars and planets. Over millions of years, gravity pulls these clouds together, forming clumps that slowly grow denser and hotter. As the pressure builds up, these clumps eventually become hot enough to spark nuclear fusion, and boom, a new star is born. Each supernova can spread enough material to form thousands of new stars, showing us how the cycle of stellar life and death keeps our galaxy growing and changing. When massive stars explode, they don't just send out light and matter, they actually shake the fabric of space itself. These ripples, called gravitational waves, travel across the universe like waves on a cosmic ocean. Think of space as a giant trampoline. When something big happens, like a supernova, it creates waves that spread out in all directions. Scientists use super-sensitive detectors called LIGO to catch these space-time ripples. These detectors are so precise, they can spot movements smaller than an atom. The first gravitational waves from a supernova were spotted in 2015, giving us a whole new way to study these cosmic explosions. It's like having a front-row seat to the universe's most powerful events, letting us hear the symphony of space itself. Our Milky Way is due for another spectacular supernova show, and astronomers have their eyes on several likely candidates. Betelgeuse, the bright red star in Orion's shoulder, is one of our prime suspects. This massive star has been acting strangely, dimming and brightening, which could be signs it's nearing its explosive end. Another star to watch is Eta Carinae, one of the most massive known stars in our galaxy. It's already had some smaller outbursts, like a cosmic warning signal of what's coming. When one of these stars finally blows, it'll be visible even during daylight and could shine brighter than the full moon for weeks. While we can't predict the exact timing, astronomers estimate we're likely to see a supernova in our galaxy within the next 50 years. Thanks for joining me on this explosive journey through the universe's most powerful events. If you enjoyed learning about supernovae, hit that like button and subscribe for more space science. Share with friends who love astronomy. Until next time.